Hi, good morning. This is Devasis Rao. So, up to previous session, we have learned all the things like types of variable, and then we learn about the definition like non-static on all those, and we learned about the memory location of the local variable, static variable, and non-static variable. Today, we'll be going through local variable and its rules. Okay, so local variable and its rules. Right. There are three rules are there. We must follow these three rules. Okay. Like rule number one, local variable cannot be accessed from another method. Okay. Because local have the scope, mean its limit is up to the method. Outside method, it will have no memory. Once the method is finished, uh, like uh, the memory will also be finished, and the local variable only have the memory within the method stack frame. So outside the method, if another stack frame is there, means outside, like there is one method is there M1, there is one method is there M2. In the M1, the variable which is being created, that will have the memory inside the M1. So while we are going to access from M2, then we cannot able to access because the memory is inside M1, not outside of M1 so that we can access. Okay, that's why it cannot be accessed from another method because its scope is restricted only within its method. Also, we cannot guarantee variable creation. Okay. Inside a method, it is created or not created. We cannot guarantee that because it's not a class level variable, so that a default value will be given to it. In the class level variable, like if we are not assigning anything, then the default value will be assigned. Like for int, it will be 0. For double, it will be 0.0. For like a reference variable, it will be like null. So some default value is assigned. But inside a method, can we guarantee? No, we cannot guarantee because that method that method may or may not be called. It leads to cannot find symbol. For example, like here class example is there. Let's do it in the ID. It will be better. There we can see it more clear. Okay. Your class example is there. Okay. So we are going to create one int a equal to 10. Okay. And we are printing it. A we are printing. Here while printing, it will be printed and value 10 will be there. Okay. But if we are going to access this variable from outside, okay, like this, if we are going to access, then it will be not be accessed because its memory location and its scope, like its limit, some limit are there. Okay. Like you have a visa for China. So you will be able to go to China and move anywhere else inside the China. But with the visa of China, if you are telling that I will go to America, then you will be thrown. Okay. So that is the case. The scope is limited. So you have a citizenship of India. So you can vote in the India and you can participate any of the elections. Okay. And you have a citizenship of India, and you will tell that no, I will go and vote in America. Are you being allowed? No, that is the case. You have a scope. So here, if we are going to access the A variable, then the compiler will give us some error. So here already the error is there. We can copy that one. Error is showing here. So here it is there. A cannot be resolved to a variable. So it is not able to find this A. What is this A? You are telling. And like this is the rule number one. Okay. If we are moving forward, then what is the rule number two? Just here is it. Okay. We are moving forward. Like rule number two. Rule number two says that local variable. Okay. Local variable should not be accessed without initialization. Okay. So local variable should not be accessed without initialization, and if you are accessing, then it will lead to compile error telling that variable might not have been initialized. Okay, this will be so we'll see this one example. Okay, so we'll be creating another class. Example one, let's say. Guys, whatever things I am doing there in the programmatically, please practice from your side. Okay. If you will not practice, then like now you will get all those things, but in future you will be forgetting all these things. Okay. So in a equal to 10 we have. Okay. It is good. Like at the time of only declaring we are initializing, it's a good. But if we are just declaring here into B, okay, and like we are going to access the A1, it is good. Here we will able to access and it will print. But after this, so if we will be printing this one, okay, Like if you'll be printing B, then like what error it will give? Let's see. It will be showing us the local variable B might not have been initialized. Okay, it is showing this compiled time. The local variable B might not have been initialized. Okay, so the compiler is not sure that this B is initialized or not. Okay, so like we cannot declare a local variable without its initialization part. Means we cannot declare it. We can define it, we cannot declare it. Okay, one more thing. So comment it out. So if we are like we have defined the a variable, okay, the a variable we have defined. So we can reassign it or we can do anything with it. A plus 10. We can do like this arithmetic operation on that. It's okay. Okay. Like we got the error that local variable b might not have been initialized. So like if we will going to do with the b plus 10, if we are going to do like this, then it will give us error, the same error it will give that local b variable might not have been initialized. It might not have been initialized and you are doing some operation with it. Okay, it will be telling that one. And like we have declared here. So in future, if we are going to assign, then we can do that also. It's okay. Now we are able to access this one. Okay, we can access this one. It can give us the value 20. We can give, and we can also do the operation, any operation if we want. Then we can do on that too. Okay, we can do any type of operation with it. Okay, and if we want to access, we can access the B. It will give us no error as it is already been initialized. Okay, okay. So if we'll run this program, here we see it's 10, 20, 80, 20. This one is the 10 variable, the value it will print like 20, it will print like 20 plus 60, 80, it will print, and it will print like 20 for A because A plus A is 10 is added. Okay, so we'll be capturing this one. This is the rule number two. Okay. So moving forward, we will have another rule. The last rule we have. The last rule states that rule number states that local variable must be accessed only after its creation statement because method execution is sequential. Execution from top to bottom. If we access it before its creation statement, it leads to compile time error, cannot find sync. Like the variable execution is always done from top to bottom. Okay. So if we are writing anything that will be accessing the variable, okay, then it will like give us that the cannot find symbol because at that time that the variable memory is not yet created because that statement is not yet executed. So we are going to access that. So we'll get the compile time error. The example, if we see it, example number two, let's say, main method we have created. Here, like we are writing a statement. Int A is there, equal to 20 is there. Okay. So if we will write a statement like this, accessing A, so what will happen? Here in this line, okay, in this line, the execution will be sequential, like this one will be executed, this one will be executed, after this one will be executed, after this one will be executed. So when this line is touched by JVM, so this line is executed or not executed? Not executed. Okay. When this line is touched, like you can say for the case of compiler, sorry, I told JVM, for the case of compiler, when this line is touched, so is this line is executed? No, this line is not executed. So as this line is not executed, so no memory creation will be there for a variable. Okay. And this line is not executed means no value will be assigned. So when this line is being executed, we are accessing the a variable, which is not yet there. Okay. So, yeah. So when we are accessing here, a compile time error is showing up. Here you can see a compile time error is showing up. If I look from the magnifier, you can see a error will be shown. Here you can see, here you can see error is showing up here. Okay. So if the error is showing up, the error is showing up. A cannot be resolved to a variable. It cannot able to find what is A. A cannot be resolved to a variable. Okay. Like here int A, here we were only declaring. We are not assigning. We means we are not initializing any value to it. Okay, we are not assigning any value. So in this line, if we are going to access the A variable, then we will get that the A is might not be initialized, like in the before example we are getting. So if we comment it out, because now this line is not giving any error because here the compiler has been stopped. Okay. After that, it have not executed. Once we comment this, then we will see error here. Now see error is coming here. So this line is executed, then this line is executed. When this line is executed, we are getting the error. What we are getting the error? This is the error. Okay. See, the local variable might not have been initialized. Okay. So the proper way is after initializing, we need to access because it's sequential accessing, sequential execution is there. So we need to access like that only. Okay. Now it's good. No compile time error is there. Okay. So if I'll capture this one. This is the rule number. Okay. So moving forward, we will have a question. How can we access a local variable value from other method? What are the ways for that? Okay. Question is there. How can we access a local variable value from other method? Okay. There are two ways of accessing. Okay. One is like pass it as an argument, and another is like store it, store it, store it using class level variable. Okay. So like we can access the local variable from other method like two ways. Either we can pass it as argument from one method to another method, and like we can store it using a class level variable. Like we can refer to any of the class level variable and we can store the value of the local variable in it. Okay. If we want to use a value in one or more method, store it using local variable. Okay. In one method and pass it as an argument to another method. Okay. This approach is recommended to save memory. Okay. I hope you. So, if you want to use a value in one or more methods, store it using local variable in one method and pass it as an argument to another method. Okay. We'll see that in example. Don't worry. So here, if we want to use a value from multiple methods of a class, store it using class level variables. Okay. If you want to use a value from multiple methods, store it using a class level variable. Okay. Like some methods we want, then we can like pass it as argument. Okay. Like I need to change this one or two methods. Okay, not more method. Because for more method, we will be using it as class level variable rather than using it as a local. Okay. One to two method is required from one method to another method, then we can pass it as argument. Okay. So this is the case. So we can go through the example like this. No need to open the STS here only you can see it. Like we have class example, let's say. We have okay. So we have a method is there static void m1 is there. Okay. Static void m1 is there. And we have another method is there static void m2 is there. Okay. 2 is there like here in q equal to p plus 10 is there. Okay. Let's say we have. this one. So like P will be declared here only, like int P equal to 10 will be there, and system.out.println println will be there. Here we will be printing P. It's fine. It's being defined and we are accessing all good. Okay. Then we are calling M1 method. Okay. The next method we are calling. Okay. When we are calling M1 method, so it will go to M1 method. Okay. So it will not, sorry, M1, right? This is M2 method. So when we are calling M2 method, it will go to the M2 method, it will go. Here the statement that int q equal to p plus 10. Do you think P will be accessed here? No, because P memory is valid up to this one. Okay. Once this boundary is finished, this curly bracket starting and curly braces ending is finished, P memory is also finished. We cannot access P from here. Okay. So we will get here compile time error. We will get. Okay. You tell that cannot find symbol P. Okay. This is a wrong. So it will print. So so it will not be accessed. Okay. Public static void main method because the JVM comes first to the main method. This M1 will not be called until and unless we call it. Okay. This calling statement. Okay. Because from here only the execution will be started from main method. From this directly when class is loaded, after that the main method will be the starting point, then the M1 will be called, then it will be going here. After that, it will be called to M2, then it will be going here. Okay, so here only. Okay, so in above program, if we want this, if we want this P to be available here, then what we will do? If we want this P to be available there, what we will do here? So we will, if we want the P to be available in M2 method, then what we will do? We will create the method like this. Static void M2 will create, and we will create one integer like this. Int P. Whatever the name might not be P. It's coming P, so it might not be P. You can make it Z also. Nothing problem is there. Okay. Z here. So we will write here like int Q equal to Z plus 10. We'll write it. Okay. And from that M1 method, okay, from the M1 method, we'll be passing the P value. Okay, here int P equal to 10 will be there, and while calling M2 method, we'll be passing the P value like this. We'll be passing P. So like 10 will be passed here. Okay, so Z will be initialized with P value. So Z value is now what? 10. This 10, it will be assigned to Z. So when you write Z plus 10, so 10, this Z will be replaced with 10 here. So 10 plus 10, it will give us 20. Value will be like 20. Okay, this is the first point. Like if you want to use a value in 1 to 2 method, then pass it as an argument. Okay, pass it as argument. Okay. So let's move to another thing. Like Then we have the topic class level variable. Okay, class level variables. So like we must create class level variable only if we want to access a value throughout the class from all its methods. Okay. If we want to access a variable, we have a requirement is there. Okay, we have a requirement is there. The variable will be accessed from all of the methods, all of the blocks, whatever you place. We can access that. So in that case, we will choose about the class level variable. Okay, or else we don't require multiple. Like in the second statement we just now read, if we want to use a value from multiple methods of a class, multiple methods of a class, then we make the variable as a class level variable. Okay, so class level variables we must create class level variable only if we want to access a value throughout the class from all its methods. Okay, this is class level variable. How can you store? Good. Let's jump. Okay, so we're good up to till now, right? One rule is there. Let's talk about that. Non-static, non-static variables and methods must be accessed with object from the static. Okay, else it leads to compile time error. C means compile time error. Non-static variable cannot be referenced from static context because non-static variable and non-static method does not get memory location directly at the time of class loading. Okay, so we know non-static variables will get memory when it will get memory when a object is created, when new is created object class. Okay, so from a static method are directly banded to a class. So class level directly banded means we don't require any object creation to call a static method. We can directly call a static method through class name. We have read that in the methods chapter. Okay, that is present in my previous video sessions. You can go through that. So for calling a static, we don't require object. We require only class name. Okay, class name is sufficient. We can with the class name we can call the static variable, static method. Yeah, it's okay. Okay, but in case of a non-static one, non-static is always initialized within the object. So if a object is not created, then we cannot call it. Yes or no? Because if we want, if we want the people to be live in a place, if we want people to be live in a place, so first of all we need to create houses for them so that they can live there. And without houses, we cannot call people. Yeah, yes or no? Because with houses, people will be living there. Then we will be just calling the people. Okay. Without houses, how can we call people? Okay. So like that only, the home for the non-static variable is the object. So if we are going to access the non-static variable from a static method, then it will give us the error like non-static variable cannot be referenced from a static content. Okay, like I can give you example here. Let's say we have a class is there, class test is there. Okay, we have public static void main method. Main method is a what type of method? It is a static method. Okay, it's a simply static method. Yes or no? If we require to access this one, we'll make it 10. So now it's a static method. So if we will defining a non-static variable here, int x equal to 10, we are defining this one, and we are going to access from the static method. Like we'll be writing a SOPLN statement, printing statement, and we're going to access this one. So it will give us the error, the above error. It will give. Like it will give that non-static variable cannot be referenced from a this non-static variable cannot be referenced from a static because here no object is created. Then how can we expect the x memory location as we discussed previously? So x is not yet initialized because x will only initialize when the object is created for this class. When the object is created for this test class. Okay, then only this x will be initialized inside it. Okay. So are we good now? So up to what we learned today, I think please go through the points and please practice well. Thank you for listening. So from next class onwards, we'll be learning like local variable, like parameter, static type of things. Lots of questions are there, and final variables, transient variables, volatile variables will be learning. Then lifetime and scope will be learning. Okay. Then static variable, lifetime and scope, that thing will be learning. And difference between static member and non-static member, those things will be learning. Okay. Thank you for this. Thank you for the presence. Bye.